All right, y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause it, and I'll go over the correct answers for you. So this is going to factor as x squared minus 5 times x squared minus 2. Those are both differences of squares, but neither one of them will factor further with integers, so we'll leave it just like that. For the math knowledge question, it asks for the measure of this angle to the sector that is shaded in. They give us the length of the arc for the unshaded sector, 7 pi. Well, we know that our circumference is 2 pi r, and they told us our radius was 4. So that means that our circumference for the whole circle is 8 pi. Well, all of it except for this part is 7 pi. So the arc length for that part of the circle must be pi. And so we can use that in our arc length formula, measure over 360, and then times 2 pi r. And we know that this is going to equal, this is your arc length formula. We know that it equals pi, and we're looking for the measure of the angle. And they told us our radius was 4. So we have a pi on both sides, so we can cancel that out. We have 1 equals 8m over 360. 8 and the 360 will reduce to m over 45. And so the measure of your angle is 45 degrees C. Okay, so we are looking at lesson 84 today. We're looking at logarithmic differentiation. So hopefully after this lesson, you'll be able to do log differentiation. So we have a function, y equals x squared over 3x plus 4 to the 4th, and we want to find the derivative. Now, we could find the derivative of this using the quotient rule. It wouldn't be that difficult. However, the next couple of examples are going to be ones that you would not want to try and use the quotient rule to find, because it would end up looking very chaotic. So what we're going to do instead is practice on this one that's not too difficult, and then we're going to go to another example where we'll use logarithmic differentiation. So what we do here is we put an ln on each side of our equation. Okay, so you add an ln to both sides of your equation. And now we're going to use properties of logs to rewrite the right side. Well, we can make it the ln of x squared minus the ln of 3x plus 2 to the 4th. That's using a property where if you are dividing, you can split them apart and subtract them. Then we're going to take the powers from both of them and move them to the front. So we're going to have 2 ln of x minus 4 ln of 3x plus 2. Now at this point is when we are going to actually take the derivative of each separate term. So the derivative of ln of y is 1 over y, and we took the derivative with respect to y, so if we put our differential there, we have 1 over y dy. Then the derivative of 2 times ln of x is going to be 2 over x, and if we do our differential, we have with respect to x, then we're going to have minus 4 over 3x plus 2, but you have to take the derivative of 3x plus 2, which is 3. And so then we have with respect to x there. So now we need to solve it for dy over dx. So I'm going to divide this right side, both of them by dx. And so I have 1 over y times dy over dx equals 2 over x minus 12 over 3x plus 2. At this point, you want to multiply both sides by y so that this one over here will go away. And now the only thing you have left to do is to actually plug in what your y is, because we can't have a y here in our function. So we know what y is because it gave it to us in the problem. So our derivative, dy over dx, is going to be 2 over x minus 12 over 3x plus 2, and then times our y, which is x squared, over 3x plus 2 to the fourth. And so all of this here is going to be your answer. So it kind of looks funny. It wouldn't look exactly like what you would have gotten for your answer if you had used the quotient rule. But it's just another way to take the derivative of a function. If you look at this one, if we were going to do it without log differentiation, we'd have to do both the product rule and the quotient rule for this problem, which is doable. It's maybe not as fun or as easy as log differentiation, but it is possible. So if you don't want to do log differentiation, you could do that on this one. But we're going to practice using log differentiation. So the first thing you do, you put your ln on both sides. So we have ln of y equals ln of the whole thing, x cubed, square root of x squared plus 1, all over x plus 2 to the 6th. And then you're going to split your right side into separate pieces. Well, we've got an x to the third, a square root of x squared plus 1, and an x plus 2 to the 6th. And so we split them into 3 pieces. These two get multiplied, are getting multiplied together, so that's why there's a plus sign there. And then this one is getting divided, and so that's why there's a minus sign in front of it. So now we move all of our exponents to the front. 3 ln of x plus 1/2, because it's a radical. So you have an exponent of a 1/2 here, minus 6 ln of x plus 2. And so now you take the derivative of each individual term. And so we have 1 over y, and we took it with respect to x, so there's our differential. We would have 3 over x dx plus 1 over 2 x squared plus 1, because I have a 1/2, so I'm just writing it as 1 over 2 times the 1 over x squared plus 1. But we also have to do derivative here, which is 2x, and then we put our differential, and then minus 6 over x plus 2. The derivative of this is a 1, so we don't have to worry about writing it. So now we're going to solve for dy over dx. So we divide each term by dx. And then we also are going to have to multiply by y to get rid of this. So all of this over here is going to get multiplied by y. So we're going to have dy over dx. We're going to have 3 over x plus 2x over 2. Well, those two 2's will simplify, so we'll just have x over x squared plus 1. Then we have minus 6 over x plus 2. And then we got to put our y, which is x cubed, the square root of x squared plus 1, over x plus 2 to the 6th. And so this whole thing right here is going to be your answer. And you don't have to worry about distributing that or anything. You're going to leave it just like that. Okay, looking at the next example. How fun would this be to take the derivative of trying to use the quotient rule and the product rule? Well, you don't even know how to do the product rule with 3 terms. You've only learned it with 2 terms. So the numerator would be extremely fun there. This is the kind of problem that you want to know how to use log differentiation instead of trying to use the product and quotient rule. Unfortunately, this would be a great problem to show your parents, be like, Mom, Dad, look at what I can do. But they would just look at you like, I have no idea what you're doing anyway. So it's a really cool problem because it looks complicated, and you're able to take the derivative of it pretty straightforwardly. But unfortunately, you can't really show anybody except for the people that know how to do calculus how awesome it is that you can do this kind of problem. So what do we do first on these? Well, you put an ln on both sides. So we have ln of y and then ln of the whole right side. And you may want to write kind of small, otherwise you're going to end up writing sideways going down the side of your paper, or having to go to a second line as you get further down into the problem. Okay, so now we're going to split the right side into 4 separate logs. So we'll have ln of y, and then the ln of the square root of 3x plus 2, plus the ln of x cubed plus 1 to the 4th, plus the ln of 5x minus 3 squared, minus the ln of x cubed minus 2 to the 5th. And then you're going to move your exponents down to the front. So we have a 1/2 for our first term. We have a 4 for our second term. We have a 2 for the next one. And we have a 5 for the last one. Okay, so now we're going to take the derivative of each one. We're going to have 1 over y dy, and then we're going to have 1 over 2 times 3x plus 2 times 3, because the derivative of 3x plus 2 is 3. We're going to have 4 over x cubed plus 1 times 3x squared, and then 2 over 5x minus 3 times 5, and then 5 over x cubed minus 2 times 3x squared. And I decided to factor out my dx instead of having to write it 4 separate times. Okay, so now we need to simplify it and solve for dy over dx. So I'm going to do that in one step. I'm going to have dy over dx, and I'm going to write 3 over 2 times 3x plus 2. If you want to distribute that 2, you can. The book does sometimes, but you don't really have to. You can leave it undistributed if you would like. And so all of that's getting multiplied by y. But we can't leave that as our final answer. We actually have to substitute the y. And so you may want to write a little bit smaller than you did on the last line. So you're writing all of the 4 terms out. And then you're going to plug in your y. So you have your square root of 3x plus 2, x cubed plus 1 to the 4th, 5x minus 3 squared, all over x cubed minus 2 to the 5th. And so all of this here would be your answer. So again, it's a pretty cool problem. You can show someone and say, look at what I can do. But it's just going to look strange and foreign to them if they've never dealt with calculus before. Okay, so now let's look at y equals x to the x. We want to find the derivative, given that the domain is all positive real numbers. So what we're going to do first is to say the ln of y equals the ln of x to the x. And then we have an exponent, so we're going to move it to the front. So it's going to be x ln of x. And so now we're going to take the derivative. Well, derivative of ln of y is 1 over y, and we did it with respect to y. For this side, we have to do the product rule. So derivative of x, 1, so we have ln of x, and then we have x times 1 over x. And all of that is with respect to x. So this term actually just simplifies to a 1, so you have ln of x plus 1. And then if I solve for dy over dx, I get ln of x plus 1 times y. And so now, all you have left to do is to actually plug in your y. So your derivative, dy over dx, equals the ln of x plus 1 times x to the x. And so this would be your answer for that. And that's why they had to state that it was a set of all positive real numbers, because right here, you can't take the ln of 0 or of a negative number. So they had to tell you that x was only going to be a positive real number. All right, so that is all for lesson today. You do get to omit number 20 on your homework, so make sure to do that tonight, and then we can go over any questions you have tomorrow.